Hey guys, welcome back. Mr. Marone here. We're going to take a look very briefly at a topic you may have seen before, but we're going to do a really thorough review of it today, and that's the idea of midpoint. So you may have seen this on a coordinate plane, and we certainly will use that at times in geometry, but you'll also see it on a number line or dealing with just a segment in geometry. So before we do that, the idea of a midpoint is it is a location or a point that splits a segment into two congruent parts. So it splits it down the middle. It's the middle point, and so it creates two congruent pieces. So if a segment was 10, the midpoint would make two 5-unit pieces. And when it comes to a coordinate plane, what we're really going to focus on today, we have a formula for that. And another way to think of how to find the middle of two things is to take an average. So we're going to do that. We're going to take an average of the two x coordinates that were given and an average of the two y coordinates that were given. In order to do that, we're going to add the first point we're given, x1, plus the second x point we're given, x2, and we're going to divide it by 2. We're going to do the same thing for y1 plus y2 divided by 2. Now, key thing here, we're looking for a midpoint, so that means it's a coordinate point. We need an x and a y coordinate. So if you get down to your final answer of your midpoint being the number 5, you've done something wrong because you're missing a coordinate somewhere. We're going to take a look at example 1, and then I'm going to let you guys try 2 and 3 on your own. So if I'm looking at the midpoint of AB, I'm going to use my two x coordinates, -3 and 4, and I'm going to put them together, -3 plus 4, and then I'm going to divide by 2 to get my average of them. I'm going to do the same thing with 2 and -2. 2 plus -2 divided by 2. -3 plus 4 is going to give me 1. So I'm left with 1 over 2, or 1/2. 2 plus -2 is going to give me 0, and 0 over anything is 0. So I'm going to end up with 1/2 comma 0 as my midpoint there. Go ahead and try example 2, both A and B, and when you come back in, those answers will be here for you. All right, welcome back in. So on the top one, when I found my average, I got down to 6/2 comma -11/2. What I'm going to do here is anytime I can divide by 2, I'm going to, so I get a +3. Otherwise, I'm just going to leave it as a fraction. In my second one, we were dealing with decimals, everybody's favorite. So what we're going to do there is do all of our arithmetic, and I got down to -3.7 over 2 and -10.8 over 2. It's not really great math practice to leave a decimal inside of a fraction, so in that case, I did find the decimal approximations there, which were -1.85 and -5.4. Now, the other big piece that we're going to look at that is going to be new is when we partition a segment. Meaning, I don't want to know right in the middle, I want to know a portion of the segment. I want to break it into equal parts, but I don't want to go right in the middle. I want to do a little bit less or a little bit more. So what you're going to do is you're going to break it into a particular ratio, a comparison of two things. And so what we're going to need to do is find the horizontal distance and the vertical distance between the 2 points. So in this example they gave us here, they want to know what are the coordinates of a point 3/5 of the way up from A to B. So what we need to do is find 3/5 of the horizontal and vertical distances from A to B. So if I start at 3 and I work my way over to 13, that's a horizontal distance of 10 units. So I would do 3/5 times 10 units, and 3/5 of 10 is 6 units. So I'm going to go 3/5 of the way, or 6 units away from 3. 3 plus 6 is going to give me a horizontal change, and I'm going to end up at 9. So I'm going to add the horizontal distance to the starting x coordinate, 6 plus 3, and that gives me a coordinate of 9. We do the same thing for y. I'm starting at -4, and I'm coming all the way up to 11. From -4 to 0 is 4, and then up 11 more is going to give me a rise of 15 units. Well, 3/5 times 15, or 3/5 of the way up, is going to be 9 units. Once again, starting y coordinate was -4, so I'm going to do -4 plus 9. That's going to give me a final position of 9, 5. So I go over to about 9 and up to about 5, and right there is going to be 3/5 of the way up on that segment. It's a little bit tricky, so if you need to go back and re-watch this, that's okay. Now, what I'd like you to do is try this example. So I'm giving you the same graph, but I've given you two different ones. The things you need to look at are both the fraction and the direction. So we're going from A to B in this first one, meaning your points you're going to start out at and add your new amounts to when we do our fractions is going to be point A. In letter B, we're going from B down to A, so you're going to start with those points in point B. Keep that in mind as you give this a try. Go ahead and give it a try. All right, welcome back in. So if you notice on this first example, I did 7/10 times 10 gave me 7, and 7/10 times 15 gave me 10.5. It's okay to get decimals. That happens. It's the same thing that'll happen with any positive number as well. It's no big deal. So what I did was I took my initial point 3 and I added 7, my horizontal change, and I got 10. And I did the same thing with my y coordinates, and I ended up with the point of 10, comma 6.5 for example 2. In part B, 4/5 times those same distances, 10 and 15, they don't change because the graph stays the same, are 8 and 12. But since I'm coming from B back to A, they have to be negative. Otherwise, if I added 8 and 12, I'd end up somewhere up here, which would be completely off my graph and wouldn't be on my segment AB. We haven't been partitioning it if we do that. So when I add my initial x point 13 and I subtract 8 from it, it brings me to 5. And when I start at 11 and I subtract 12, I end up at -1. So my point is 5, -1. Once again, these partitioning ones are tricky, so take your time, think about them, really get that practice in as you look at these. If you have any questions, bring them into class tomorrow and we will look at them then. Have a great night, guys. Bye-bye.